Let's apply the Gauss-Jordan elimination process to determine the reduced row echelon form of this matrix A. So the first step, as we recall, is we have to locate the leftmost column that does not consist entirely of zeros. So for our matrix A, that is not a problem because all columns are non-zero. So the next step is to make sure that in the first row, the leading entry must be a 1. Okay, so that is not the case for our matrix. So what we have to do is to apply a row operation, an elementary row operation, to make this a leading 1. So we can interchange row 1 with another row. So the most convenient row to use is row 2. So let's do that. Let's interchange rows 2 and 1. So doing that will give us this matrix. Okay. Now, the next thing that we have to do is to eliminate the entries that lie directly below this leading entry, or this leading 1. Okay, and so we have to perform some elementary row operations for that. So to eliminate this entry, we may add rows 1 and 3 and use the result to replace the third row. Okay, so that process or that step will give us 0 here, 2 here, 0 here, and 5 here. Okay. Applying the same idea for row 4. So let's multiply -2 to row 1 and add the result to R4. Use it as our new R4. Okay, so we'll have 0 here, -4 plus 3, -2 times -3 will be 6 plus 0, and -2 times 1 plus -3. Okay, so after doing that, we have eliminated the entries directly below this leading 1 in the first row. So the next step is to consider the submatrix obtained by covering the top row. Okay, so we're talking about this 3x3 matrix. We apply again steps 1 to 4 to this 3x3 submatrix. So the first step is to make sure that the first row has a leading 1. Okay, so in this case we are done. So we just need to make these entries equal to 0. Okay, so let's do that by first adding row 3 to -2 times R2. Use it as the new R3. Okay, so we'll have here 0, 0, -4, 2 plus 5 will be 7. Okay, and let's also get rid of this entry that is obtained simply by adding rows 4 and 2. Use it as the new R4. So we'll have 0, 0, 8, and negative 6. So here we have eliminated the entries directly below this leading entry in the second row. So we repeat again, this time to this submatrix obtained by covering the top two rows. Okay, so the first step again is to make sure that the leading entry is a 1. So which means this entry has to be 1. So we have to multiply the third row by negative 1/4. Okay, so negative 1/4 times row 3, we'll have 1 here, negative 7/4 here. Okay, and now we use this third row to make this entry equal to 0 to eliminate the 8. Okay, so we multiply negative 8 to R3, add the result to R4, use it as the new R4. Okay, so we'll have 0 here, and then you must have here positive 14 minus 6, that's 8. Okay, and finally, well, we apply the same thing for the remaining submatrix. So it's only 1 by 1, so we just need to make this a leading 1. We need to turn this into a leading 1, so we divide or we multiply row 4 by 1/8. Okay, and so we will obtain a matrix in row echelon form, that is row equivalent to A. So this is an rref, no, for our matrix A. Let us proceed further to obtain the reduced row echelon form of A. So we just repeat the Gauss-Jordan elimination process, but this time, okay, because we are taking or we are computing for the rref from the ref, we start at the lowest row, at the bottom row, okay, and work our way up from right to left. Okay, so earlier when we were deriving this ref, we started from the top row, okay, worked our way down from left to right. So this time we'll do the opposite. Okay, so the first is we will use row 4 to eliminate these entries, okay, lying directly above this leading entry. Okay, so to do that, we will multiply -1 to row 4, add to row 1, and that changes our row 1 to this. Okay, so let me put the fourth row here. We do the same for the second and third rows. Okay, so for the second row, for instance, we may just add row 2 to row 4 to obtain this new row 2. Okay, to get rid or to eliminate this entry, we multiply 7/4 to row 4 and add it to row 3. Use the result as the new row 3, so we'll have 0 0 1 0 here. Okay, so as you can see, we have eliminated the entries directly above this leading entry at the bottom row. So we just apply the same idea to eliminate these other non-zero entries. So remember, in a reduced row echelon form, okay, if a column contains a non-zero, or if a column contains the leading entry of some row, okay, so other than that leading entry, everything else must be 0. Okay, that's why we are eliminating these numbers. So to eliminate these, we use R3. So for instance, for R1, we multiply 3 to R3, add it to R1, you get 1 2 0 0 in the first row. Okay, in the second row, we multiply -2 to R3. Okay, add it to R2, use it as the new R2. You'll get 0 1 0 0. Almost there. You just need to perform one more elementary row operation, that is adding R1 to -2 times R2. Okay, that will produce 1 0 0 0 in the first row. And now we obtain a matrix that is in reduced row echelon form, which is row equivalent to A, and thus we say that this is the rref, or the reduced row echelon form of matrix A. Note that this matrix is nothing but the 4x4 identity matrix. The remark earlier tells us that if you obtain another matrix in reduced row echelon form that is row equivalent to A, then that matrix must be the same as the 4x4 identity matrix. Okay.